Okay, well, this is the start of a brand new unit. The name of the unit will be the polynomials unit. We're going to do a whole bunch of things today. Mainly will be a video on some things you probably already should know. We just took our first remote test. Hopefully that went well for everybody. Now we're going to begin our brand new unit. So take a moment if you need to, copy down the question for today. You'll find your assignment, as always, in the classwork section of Google Classroom. And again, we encourage you to make sure that you're submitting your homework through Google Classroom. That way we can check it. All right, I have an interesting little question for today's do now. Let me get my picture out of there. Now, it seems like a really simple question. It says add and then subtract the following two numbers. So add 586 and 231. Now, I'm just going to write it down. You know what? Let's not even subtract them. Let's just add them. And I think we get 817, if I'm doing that correctly. Now, why do I have you do this as today's do now? Because what I want you to notice is just instinctively, we added the 6 and the 1. But if we think about why we did it, it's because they're both in the ones place. They're both the same type of number. Why do we add the 8 and the 3 together? Because they're both in the tens place. They're the tens. The tens get added to the other tens. Why are the 5 and the 2 added together? Because they're the hundreds. The hundreds get added to other hundreds. It's something we've grown up knowing to do, and often we don't think about why we're doing it. Well, I want to keep this same thing in mind, that we're going to add numbers that are the same to other numbers that are the same today. Okay? So with that in mind, let's get right into today's stuff on what a polynomial is. Again, some of this might be review, so take notes as necessary. All right, so a polynomial is just some sort of mathematical expression. It does not have an equal sign or anything to it. And a polynomial is made up of what we call terms. You see that there in red. A term is separated by addition and subtraction signs. So that's how you know that you're onto a new term. So for instance, in this first one of the terms is x, and then since there's an addition sign, the next term is positive 2. We actually take the sign that's with it. So we say it's positive 2 and x are the two terms in that one. Okay. Now, that other one, the next one after that, says x squared minus 12x plus 4. That thing actually has three terms. One of them is x squared. One of them is negative 12x. And the last one is positive 4. That thing has three terms. You probably heard we call something with three terms a trinomial. That first one has two terms. We call that thing a binomial. Just a specific name for those types of polynomials. Okay, now, absolutely sure that you're probably aware of the phrase combining like terms. Anytime you have an expression, a polynomial, that has terms that are alike, you can combine those things. Meaning, when I say combine them, I'm really meaning we're adding them together. So in this first polynomial, 4x minus 5 plus 3x, the 4x and the positive 3x are like terms. Therefore, they can be combined together and they will give us that 7x that we get over here. Now, the negative 5 doesn't have a partner, so we're just going to rewrite it as minus 5. Okay, look at that next one. 6x squared plus 3x minus x squared plus 5x. I mean, you can already see the answer here. I already have it, but to see where that came from, the like terms were 6x squared and negative x squared. So think of that as like a negative 1. Okay, negative x squared just means there's 1x squared. So 6x squared plus negative x squared, that's where we get the 5x squared from. The 3x and the 5x combined to give us the 8x. And there's our final expression. Now, if you're wondering, well, why can't I combine these two things together? They both have an x. Yeah, but one's an x squared and one's an x. Those terms are not considered to be alike because they do not have the same exponent. Now, we do typically write them with the highest exponent down to the lowest exponent. In this case, the exponent here is 1. I know it appears like there isn't anything, but there's an exponent of 1. So that's typically the order we write that in. We call that standard form, when you write it from the highest exponent down to the lowest. Okay, moving on. When you're subtracting a polynomial, same idea as combining like we did in the last one, except that since we're subtracting, we have to make sure that we distribute this negative here first and then combine like terms. And you go, well, what about this first one here? Did you distribute anything there? Yeah, we distributed a 1, but that didn't change anything. Anytime I multiply 1 by something, I get the same thing anyway. But watch what happens when I distribute a negative 1 here. That becomes negative 2x squared. This one becomes negative 1 times negative 4, which is positive 4x. And then negative 1 times positive 6 is negative 6. So when you multiply by a negative, that does affect some things. Now, at this point, we look for some terms that are alike. Well, 5x squared and negative 2x squared. Notice I took the sign that was with it. They're alike. Those combine to be 3x squared. 3x and 4x combine to be 7x's. And negative 1 and negative 6 combine to be negative 7. And notice the order I wrote it in. Highest exponent down to, well, something that doesn't have an x at all. So that's considered standard form. Okay, if this sort of sounds familiar to you, you're right. We do this at the end of 8th grade. So this is coming back from the very end of 8th grade. All right, now here's just the animation part of it. Okay, I want you to take a look at this. And I don't know if you can read that because I didn't realize the format was going to do this. It says, be very cautious of the word subtract from or subtract blank from blank. All right, take a look at this problem here. When negative 2x squared plus 4x plus 2 is subtracted from x squared plus 6x minus 4, the result is, now which one of those do you think is the way to express that? Because here's what we do know. We know that in subtraction, the order matters. Well, the good thing I want to note about each one of these examples, although only one of them can be right, the good thing is that both examples put parentheses around our expressions. We got to make sure that we do that when we go to subtract, because if we don't, we're going to forget to distribute. Okay, really, really important. All right, so let me reread this again. So it looks like I'm going to be subtracting negative 2x squared plus 4x plus 2 from x. So that means it's going to be this one, because this is getting subtracted from this thing here. So even though it's not written in that order when we read the problem, that's actually the order that you're going to write it in when you set it up. And then I'm not going to do the whole problem out, but we would distribute this negative here to all the terms and then combine like terms. You'll get a chance to do that for homework and practice. All right, last question. It's also in Spanish as well. It says a rectangular park has a length and width represented by the expression 3x squared minus x plus 10 and x squared plus 4x minus 1 respectively. What would the amount of fencing needed to enclose this park represented as a polynomial in simplest form? All right, so I'm thinking this is something to do with perimeter. Why don't we pause, figure out what the perimeter of this rectangular park would be in simplest form, which means combine like terms. Okay, hit pause, go ahead and give it a shot. Okay, there you have it. I tried to color code the like terms for you so you can see where I got them. I bet you some of you only combine 2 of the things. Don't forget that a rectangle has 4 sides, the 2 lengths that are the same length and 2 widths that are the same width. So you really had to be adding all 4 of those things there together. All right, if I fooled you on that one, don't forget for next time. All right, good luck with this. And if you need to, I'll be online tomorrow, as always, at 9:40 for our Google Meet.